Welcome back, C++ code lovers. To this session of C++, we're now going to start talking about arrays. So we talked about functions, we talked about selection structures, if-else statements. Now we're getting to the more interesting part of programming, or the pinnacles of programming. And arrays are part of a bigger picture or a bigger concept called data structures. Data structures. Okay, so in your RAM or your hard drive, there must be going to be RAM because RAM is what the CPU accesses, and that's why the CPU stores its its variables and that's memory it uses, right? Of course, may argue about registers and cache and everything like that, but it's a RAM which we're most interested about. You can check out the first lesson, I think maybe a second, I'm not sure, on memory and stuff. But in your RAM, you have well, not the hardware part of it. The hardware part of the RAM has capacitors and transistors. Capacitors and transistors. And have to be an electrical engineer really to just see how an on and off signal prints out or sets out values of ones and zeros binary, and how you have to continuously keep on charging the capacitor, the kind of logic gates you make with the transistors. But we're not going to worry about any of that. For now, we're just worried about the conceptual aspect of the RAM. Don't think of it in the hardware aspect. In the hardware aspect can be too much of work to think about, which we don't even need, or at least for now, unless you're an electrical engineer. But I'm not sure an electrical engineering major anyways. But let's look at the conceptual aspect of the RAM. Okay. So in the conceptual RAM, imagine of it being a box of some kind. And this box is maybe a shelf in the library with places where you can store your books, right? Okay, these are like memory rolls. Okay. I just can't access things in the RAM just like that. And computer scientists have built up ways to access RAM in a more efficient way. So you may hear of things called heaps, like memory structures, the way you can conceptualize what the RAM is like, and stacks. Heaps and stacks, right? Okay. Um, you don't even have to worry about this, not so much, but just think of it of a heap as the random assortment of things on your RAM, okay, and the stack as somewhat an organized thing, okay, an organized piece of structures put one on top of the other. So let's say you're making a stack of rocks. So this is organized. A heap of rocks would just be disorganized rocks, just randomly assorted. You don't even really care about the arrangement. Okay, but you don't even have to worry about any of that really. And again, not an electrical engineer. Well, maybe for computer science, if you want to do algorithms and data structures, helpful to know some of these things, I guess. But yeah, you don't have to stress not much on this. Okay, just a minute. Alright, so here goes. We've been working with atomic data types, atomic variables. That's variables which can only store one thing. Okay, so I wrote out things like int age, can only store the age. So you're like int age double your bank account. Just imagine there's some huge amount of money in there, double bank account and whatever. But these are atomic data types. So these are atomic. It means you can only store one thing. Let's go back to this concept of RAM. Let's say you wanted to store more than one thing. So maybe an atomic dot set can only occupy one cell of RAM, right? One cell of RAM. I think the more correct one would have been RAM cell, but whatever. So and let me just change that. Oh, it just doesn't matter. But your atomic dot set can only occupy one cell of RAM. But let's say you want to occupy many of them. You want to store maybe the grades of a student in different subjects, and the student has 8 subjects. How do you solve those? And then you have to find the average, right? And then you have more than one student. So how are you going to store that? That's where arrays come in. So arrays, now back to the concept of data structures. Arrays are linear data structures. Data structures. Okay. So they store one thing one after the other. And then if you go back to the RAM, you don't do it like that. If you go back to the RAM, what's an array? Okay, cool. So if you go back to the RAM, linear data structure is going to store, it's going to occupy a contiguous slot in memory. Contiguous, just one way or another way of saying continuous slot in memory. This is going to occupy maybe 3 cells, 4 cells, 5 cells, or n cells, n being user defined. Okay. Although it's again there are own disadvantages because it may occupy more space than you need, but it's going to occupy a contiguous space in memory. Now the other kinds of data structures, okay, for example, you have graphs, you have linked lists, you just have lists in Python, but let's say C++, you have graphs, you have linked lists, you have maps, and you have dictionaries. So this is just one way of occupying your RAM. Not one way, sorry. Many ways of occupying your RAM. These are not linear like arrays, so we're going to work with arrays. And since our C++ course is simple, we're just going to work with the linear data types. The linear, the memory allocation is going to be contiguous, and you're going to be storing more than one item at once, right? Now let's get to the code and let's see how that works. I'm going to use Visual Studio Code, and you should really have the freedom to change between whichever one you prefer. I'm going to make a new C++ file. I think I'll call it arrays.cpp. Right, there goes. So you go like include our stream. Okay, that's the standard format for any C++ file. Maybe I should increase the font speed. I'm not sure if it's visible. Okay, so we're going to make an array to store integers. So I'm going to say not doubles, integers. Let's call those grades, grades of the student. Now to use an array, you have to use those square brackets. You can call them brackets, square brackets. And then you have to specify beforehand the number of items you're going to store. That's one disadvantage of arrays, right? You have to specify the number of items. So it so happens that people specify more items than they need, and that leads to allocation. If you're going to allocate memory, let's say if you want to store 3 things, it's going to the RAM to reserve space for 3 things. Okay. Now you can check the size of this array. Oh goodness. You can check the size of this array with a method called size of sum. Yes, you can say cout size of grades. Okay. So here I'm going to check the size of this array. And really we're going to spend a lot of time practicing questions on arrays because arrays, data structures when combined with algorithms are like the bedrock of programming. It's both the bedrock and the cherry on top of the cake. So just going to compile that. I'm going to say G++, arrays with CPP. Ah, goodness. I should probably kill this terminal. Okay. I kill that compilation again, and I say G++ arrays.cpp. Did I save that? I think I forgot to save. Let's go back. I'll keep on calling dogs instead of arrays. That compiles. Okay, 12. So in terms of bytes, it's 12 bytes. And one integer is 4 bytes. 4 bytes, multiply that by 8 to get the number of bits. But here one integer is 4 bytes. So what you're telling the compiler is reserve space in memory for 4 bytes. And that's going to be for like 32 bits, right? 32 bits. So reserve space in memory for 32 bits or 4 bytes. And then you can print out the size of the array. So this can store 4 bytes. Now to access the elements of the array, you start counting from 0. Okay. So start counting from 0. It shouldn't be so strange that you start counting from 0. If you know anything about thermodynamics, then you know there's a zeroth law of thermodynamics, the first law, second law, and third law of thermodynamics. Okay. Now the third is really the fourth, but the number from 0 to 3. So that's how arrays are referenced. So you start counting from 0 going up. Let's add elements to this array. If I start, I can initialize these. I use these braces to initialize. So let's say 1, 2, 3. Those are the integers I'm storing in my array. And I can print them out. So to print them out, you have to use a loop. Okay, so use a loop to print out all elements. But if you don't want to use a loop, you can just say south grades element at I. Oh, sorry, at 0 or at 1. So element at 1, this is going to be 0. Element at 1 is going to be 2. So I'll just go back there, run terminal, new terminal. Power that, run that. Goodness, I didn't save it. Okay, that's saved it. I compile it again and run it again. So it's printed out to, that's element at position 1. Okay, so this is position 0, position 1, position 2. Now notice what happens if I say element at position 3. It's going to give me an error out of index exception because position 3 isn't part of the array. So I'm going to compile that. When I try to run that, okay, sometimes it may give you what's not there, sometimes it may give you an error. But here I have what's not there. It's just a random number from somewhere in space. It's getting from another place in the ROM. Okay. Sometimes you may get an error, so it just depends on what programming language you want to use. Let's try 6. So that's not part of the array. Okay, I'm still getting this random number. Let's try to save that and run it. Okay, still getting the same random number. But yeah, in most cases you're going to get an error, an out of index exception. And let's try something. If I want to use a loop to access all the elements, I'm going to use a for loop. It's most preferred. You can still use a while loop. So you say int I is equal to 0, or I is less than 3, I plus plus. I'm just going to say cout, print out the element at grades, I. Okay, I'm going to run that and I'll save it. Looks like I didn't save it. So I've saved, then I'll compile it and run it. So that goes printed out 1, 2, 3. Okay, printed out 3 elements. Those are elements in my array. But let's say I go out of bounds. So in other programming languages, you get an error. Sometimes in C++, depending on what you're using, you get an error. Okay. I think that's my compiler. If I run this code in dev, I should really have an error. So I'll save that. Let me save it again. Then I run that. Okay, there goes. I'm not getting an error. But let's try the same code in dev and just show you that I'm going out of bounds. So this is an error. It should give me an error. I'm just going to copy that. I'll go back to dev and I'll paste that code. Okay. When I run it in dev, I'm just going to compile and run. Okay, looks like I have the same thing. That's giving me a random number. Cool. Because these are integers really. But yeah, just getting a random number from the ROM. Okay, so sometimes you may get an error. Now let's try to make them doubles. So again, it can be endless if you want to store. Again, it has to be the same data type. You're storing more than one item at once, so they can be anything really. Yeah. Again, still getting, you can see those random numbers because we're going out of bounds. The array is only limited for 3 things, but you're going for 4. Cool. I guess C++ found a way to handle that better than Java and Python and in other languages. But yeah. So this is an array of doubles, the data type, the name of the array, and here I'm just initializing the arrays. Okay. And let's go back to that month problem we had. And remember we said there's a better way to do it instead of having to write if else statements, whatever, blah blah blah. You could use arrays and a loop. So we can make a string of months. Yeah, the number from 1 to 0. This is going to be 12 months. So this is a string array. So I'm just telling the computer that reserve space in memory for me to store 12 strings. I can initialize it. You don't always have to initialize it. You can create January, comma, February, comma, March, April, May, June, July, okay, that's an array of the months of the year. So to print them out, I just have to print out those months. So just use a for loop. I just say int I is equal to 0, I is less than 12. I'm just going to say I plus plus. And I'm going to print out the months of the year. I'm just going to see out months at I. So that's how you access an element in the array. You just write out the name of the array, square braces, and the index. Again, remember, this is index. So this is 0, 1, 2, up to 11. Okay, so this is the 11th element. That's the first element. Sorry. Okay, that should be the first element, second element. Don't mind this. what you're seeing there, but that's how it was. So terminal, new terminal. I'm just hoping I save this so I can print out what's in the array. Okay, so there it goes. It's printed out January, February, March, April, May, June. All I have to do is just write out one CR statement for the month and the loop keeps on executing that for me. And let's say I wanted the user to enter a number, and then when they enter a number, I give them a month of the year. Cool. So just say CR, enter a number for the month of the year. And there, let's say here int index. The number is going to be index. This is going to be C in index. So we're going to say if index is less than 0, I mean, you don't want it to be 0. In fact, if it's less than 1, you don't want it to be less than 1, or index is greater than 12. Then we're going to say cout invalid input. Okay, valid input. Else, it means the input is valid, and what we're going to enter, we're going to print out cout the month. If I have to make it interesting, the index month. Oh, sorry. Month is then you call out your month. So remember, we made a string of months. So I'm going to say months at now. Remember, the counting has to start from index 1 minus. It starts at 0, so it's going to be index 1 minus index minus 1. Enter. That's one. Now this is just a few lines of code. It's done the same thing as we did the other time when using switch case and when using multiple if else statements. I don't know if I still have that messy code, but I'm just going to save that. So first off, it prints out the month of the year up to December, 2020 December. Then it asks you to enter a month for the year. You say until the fourth month. So the fourth month is April. Really that simple. And let me try to run it again. Let me try the 13th month. It's going to give me invalid input. Let's try to run it again. I want the first month. The first month is January. Okay, maybe I should have worked on that, but yeah, that counts. Yes, so there you have it, guys. That's about arrays, and you've seen how we can shorten the code on arrays. You can check out, yeah, I think the other functions we made on the other files made on months using control structures to the really lengthy code. I think it's right here. Okay, so I had to check if case 7, case 8, case whatever. And if I try to run this, let me just try to run it again. So I'll compile it. I say G++ months s.cpp. I compile and I'll run it. .exe. Enter the number of the month, 5. The month is May. Okay, now look what I had to do here. All this messy code. I check out for all the cases and then write find the month is May. And let's see the power of arrays and loops and the power of programming. Here, all I have to do is, I can comment this out because I don't need it. Let me just delete it. So I've just made an array of months. There it goes. I don't think I need this array also. These are not used. Okay, this is what it does. So it does. it's a few lines of code. I'm going to say terminal. I'm just going to compile arrays.cpp, and goodness, okay, still running on the previous code. Looks like I didn't save this one. Save. Okay, compile that and run that. Enter the number of the month of the year. 6. The month is June. Cool. So it looks like I have more output. Enter the number of the year 5th. The 5th month is May. Same thing as what happened in the previous one. If I compile this one, C++, month S to CPP, I run that, EXE, into the number of the month 5, the month is May. In here I had few lines of code, and this code is more efficient, by the way. Remember the dry concept, don't repeat yourself. Here I have lots of lines of code, to carry out the same output. If else statements, it's even worse. The code even looks dirty. I had to check if it's any of these messed up. Carry out the same output, right? Okay, I still get the same output. So seeing how arrays and loops are better than just using single selection instructions. When you mix up everything else and you put in a bit of control structures, switch case statements, you make more efficient code which runs servers and makes games. That was that for today, guys. Arrays. Have a wonderful day.